Now it's time to make these problems a little bit more exciting by putting them in the context of a football game. So that's what we're going to be working with today, is working with these quadratics and picking out these key characteristics, and not only picking out these key characteristics, but interpreting them in the context of a problem. So if you haven't yet, go ahead and read the word problem that corresponds with this table and this graph. I think it starts off by saying Coach Clark is coaching the boys to help improve their throws. Go ahead and read the word problem a couple times and make sure that you understand what's happening in this problem. Make sure that you understand the context of the problem. And if you don't understand the word problem, make sure that you talk to me before you continue the video, because if you don't, then it's just going to be really confusing from here on out. So the very first thing that we do here is we've got a T-chart. Now this T-chart is not fixed, but this T-chart represents the position or the height of this football at different times. Okay, so it's not complete, so the first task is you need to go through and calculate the height for every single time that's on the left-hand side. Now I recommend go through and try this on your own first. All you have to do is something like this. Okay, so if I want to know what the position is at negative 0.5 seconds, I plug in negative 0.5 into that function. So I do f of negative 0.5. And remember yesterday we talked about what that notation means. And of course this notation is telling me just plug in negative 0.5 into the function, type it into your calculator, and see what the function is equal to. So this is equal to negative 16, and we've got x squared, so I need to put parentheses, negative 0.5 squared. Now a heads up, if you do not put the parentheses around your negative sign in your calculator, your answer will not be correct. So if you're using a calculator to evaluate this, make sure that your negative sign is inside the parentheses here. And then we do plus 50 negative 0.5 plus 6. Now, if we just type that into our calculator, what you find is that your function, whenever it has the input negative 0.5, our output is negative 23. Okay, negative 23. Now, I want you to go through and try all of these on your own before I put the correct answers up. So go ahead. Try evaluating 0 and 1 and 1.5 and 2 and 3 and 0. Again, actually, we don't need to do that last one. Let's just go ahead and scratch that. 0. Try evaluating the corresponding y values for all of these input values. Because remember, this is part of our domain. We're plugging in just some random domain values, and we're seeing what points these correspond with on our range. Okay, so go ahead. See if you can do these calculations on your own, and then continue the video. Okay, so hopefully you have some numbers that you can compare with the ones that I'm about to put up here. So when you plug in 0, n for x up here, you can see that your first term and your second term are just going to go away, and you're going to be left with just the number 6. Just the number 6. And when you plug in 1 into the function, okay, you get negative 16 plus 50 plus 6, which gives us a positive 40. So we have positive 40 here. And of course, when we plug in 1.5 in for x, we're going to get 45. We get a 45 here, 45. And when we plug in 2 into this function, we find that f of x is equal to 42, just write 42 here. And then when we plug in 3 in for x, we find that our function is equal to the number 12. So the number 12 there. Okay, so now our next task is that we want to plot these points on the graph and label. All right, so if I want to plot my first point, we start by determining which one's on the x-axis and which one's on the y-axis. Now, it may be obvious to some of you, but look at the time. Okay, we were plugging time in for the x value, so you'd probably think the time is on the x-axis, and it is in this case. So time is on the x-axis. So I'll just put a T down here to remind us of that. And our height of this football is on the y-axis. So I'll just go over here and put an H just to make sure that we know that. H, so height is on the y-axis and time is on the x-axis. So we need to find negative 0.5 on the x-axis, which is right around here, in between the 0 and the negative 1. And then we need to make our point at y equals negative 23. Now you may notice that our function, or our graph, only goes down to about negative 8, a little bit more than negative 8. So the negative 23 is going to be way down here somewhere. And since I don't have room on my graph, I'm just going to skip that point. So let's go on to the next one, 0 and 6. So we go to 0 on the x-axis and then go up to positive 6 on the y-axis. And right there's our first point. Okay, right here. I hope you can see that. It's kind of hard to write on this program that I'm using, so I'm not going to label every single point like it says to do here, but I will label the first one just that way you can see what I want you to do, 0 and 6. So I have labeled that point. Now for the rest of the points, I do expect you to label each point like this, just to make sure that that you're plotting the correct values, but I'm not going to do that on here just because it's going to get a little cramped and it's kind of hard to write this small on this program. So I go here, 1 and 40, scroll over to 1 and then go up to the 40, and you can see our next data point is there, 1 and 40, and then I go to 1.5 and 45, so here I go 1, 1.5, and then up to 45. Hey, look at that, that's our vertex. That's our vertex right there. Okay, now we go to 2 and 42. So 1, 2, and then up to 42. That's another point. Okay, there's my 42, and then I go to 3 and 12. So 1, 2, 3, and then up to 12. And you can see that every single data point lies on that red curve that I had plotted for you guys. Okay, which is what we would expect. So typically, the way that you're going to work with these kind of problems is going to be backwards. So typically, you'll plot the data points first, and then try your best to sketch a curve like this, or to use some sort of data analysis software to perform this curve fit for you. But now you can see that we have all of our data points, and they fit perfectly along that curve that we have in red. So now let's go on to the next part. Identifying our domain and our range and interpreting these in the context of this problem. So the domain. Let's start with the domain. These are all acceptable x values that we can plug into the function. So the domain, what do you think the domain is for this particular function? Yeah, for this particular function, it's all real numbers because there's no limit to what the x values can equal. So our input values can be from negative infinity all the way over to positive infinity. The domain for the function itself is not restricted. So the domain, we'd say, is from negative infinity on the x-axis all the way over to positive infinity on the x-axis. Now, what do you think? The domain in respect to the content. So this is asking us to interpret the domain in the context of this problem. Now, how would you describe this? To describe the domain in respect to this particular content. And the domain in this particular case, if we go back, remember we said that the domain are all x values. And remember we said that the domain is time. So the domain in this case, okay, if we want to interpret the domain is time. Now that being said, okay, if our domain is time, does the original domain for the function in general, does this apply when we think about it in the context of time? Yeah, so hopefully you were able to say that no, it doesn't make sense for time to be negative. Okay, time cannot be negative. Now we've plotted this function and it seems to work just fine when we plug in a negative value. But when we think about time, time cannot be negative. It has to be moving forward. It has to be positive. So when I go here, our domain actually is restricted to positive values. So if I want to write that in the content, in respect to this content, we would say that the domain includes 0 That's why I have the bracket there, and can go to positive infinity. Okay, the time can increase to positive infinity. So the domain in general is from negative infinity to positive infinity. But when we think about the domain in respect to this content, the domain is time. Okay, and time cannot be negative, so we're limited by having the domain from 0 to positive infinity. And another way of writing this is we could say that x has to be greater than or equal to 0, but less than or equal to, well, really, we don't even need that second part. We can just get rid of that. This is all we need. And some of you may prefer that I write it like this. X is greater than or equal to 0. Okay, so that's our limitation. Both of these are saying the exact same thing, is that x has to be greater than or equal to 0 because time can't be negative. Now think about the range in the context of this problem. What is the range in general? Okay, first write what the range is in general for this particular function. Yeah, so hopefully you were able to say that the range for this particular function, okay, goes all the way down, okay? So we're looking at the y-axis now. If we're looking at the range, we're looking at the y-axis, and we go all the way down, and there's no limit to how far down we go on our function. See, look over here. It drops down, 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 really, really far down. Oops, went to the next slide. So it goes really, really far down. So our range really needs to start at negative infinity, way down here on the y-axis. Negative infinity, and we put parentheses negative infinity, but there is a limit to how high it can go. So when we're looking at this, we go up, 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 up the y-axis, all the way up until we get to the maximum point, which looks like it's around 45. So 45 here is where our other part of our range is going to go. So we've got 45, and 45 is included in this range. In fact, we actually calculated the 45 over here when we plugged in 1.5 into this function. We calculated 45. So when the input is 1.5, we get an output of 45. So that's our range. But in the context of this problem, what is the range in respect to the content? What do you think? So this is what you have to think about. You have to think about the limitations in the real world. So let's go back to our graph. Now remember that we said that this ball, when it's initially thrown, it's at 6 feet above the ground. I think is what we had. Yeah, 6 feet above the ground. Okay, then it goes up, up, up into the air, and then eventually it reaches to a certain point and stops just briefly and then starts to come back down. Okay, this is when it's coming back down toward the earth, and eventually it's going to reach JJ's hands and then hit the ground. So in the context of this problem, can this ball go below the ground? And the answer is absolutely not. So really our range has to be, in respect to the context of this problem, we are limited. Okay, we are limited to the constraint that the ground is 0, and we can't go below the ground. So really, our range is going to be from 0, from y equals 0, all the way up to 45. So the range in respect to the content is going to be, because the range is the height, okay, the range is the height, the range is going to be from 0, 0, up to 45, and then another bracket. Okay, and another way of saying this would be x, let's do this, x, okay, has to be greater than or equal to 0, or it has to be less than or equal to 45. So both of these are saying the exact same thing. One is just in bracket parentheses notation, and the other is in an inequality notation. Okay, so that's it for this this portion of the problem. So go ahead and go on to the next educated video, but before you do, I'm not going to tell you how to find the x-intercept meaning or the y-intercept meaning. I want to challenge you to do this on your own. So go ahead, answer the next 2 squares, find out what the x-intercept means, and find out what the y-intercept means, and then go on to the next EduCanon video.